see you all. This is not the very first time I'm here. I've been doing this a couple of times before. What we are trying to do today, or at least what I'm trying to do this morning, is to set the scene basically for the rest of the week. You will hear a lot of talk about technology, applications, the way to do things. But what I'm trying to do this morning is to make clear to you that there is something behind it, which is really the reason why we do all this stuff. Why are we involved in automatic identification in all its different technologies? And that's what we will hope to cover today in the first talk this morning. And basically, what we are trying to do as a technology is improve productivity, profitability, and customer service. I think that is really, those are the three elements that are very important. I was on a business trip in India many years ago, 85 as a matter of fact, and I was trying to introduce barcoding into India through a lady who approached us at the time and said, I want to get involved in barcoding, I think it's a neat thing. And as we were developing the first presentations, it became very clear that productivity was not really an issue in India because of the availability of relatively cheap labor and some other issues and the cost of doing business. So we developed a different strategy. We didn't call it profitability, but we called it accuracy. Because very often when labor is cheap, the accuracy doesn't necessarily go up. And so we developed a new strategy. So this is more for the Western world, productivity, profitability, and customer service. And you find barcodes everywhere. I remember the early days, and I'm not going to tell you how long that was, how long ago that was, but you really, not just in your supermarket, which is where most people say, yeah, I've seen barcodes, and they're used, but they are very instrumental in making manufacturing, distribution, supply chain, healthcare, financial and military environments more efficient. And because in all these cases, there is a business case to be made. In all these situations, you really need a cost justification to implement the technology that we're discussing this week, the Auto ID technology, in a big way. Because there's a first phase where technologists often start, or IT people start, playing with the technology and trying to discover what can be done with it and how would we implement it and so on and so forth. But if you want to go on full scale, then of course we really need the cost justification, and that is the business case we're going to try and make. In the military environment, it is definitely a very important technology, because if you are in rapid deployment and you can't find the stuff that you're looking for, if you can't find your bullets and your rockets, then you may easily get into trouble. And as a matter of fact, the military was one of the early, not the very earliest, but one of the early adapters of this technology. And we'll talk a lot more about other environments. What the technology is not is the right solution for every problem. I mean, it's not a do-all, fix-all for all the different issues that may be around in the different application environments, in the different industries, etc. And it's not a cure. It doesn't help you to solve bad business practices that you may have in your organization. It doesn't help them. What it does do, when you have bad practices, it makes them a lot more speedy, and you get into deeper trouble more rapidly if you don't change and adapt the fundamentals. That's quite critical. It's not all things to all businesses. The environment changes very much. It's very different whether you're in a retail supply chain or whether you're in a healthcare environment. In a healthcare environment, it's a matter of life and death. There is the some famous statistic that has been around for more than 30 years in this industry, that every year in the United States, 7,000 people die because of wrong medication. Now, if we can cure that, and I don't think anybody has really followed up and seen what the current situation is and whether that number has gone down because of the implementation of the technology. If anybody has better numbers, then I would appreciate being corrected here. But the case in a healthcare environment is different. Doesn't mean that in the healthcare environment we don't have a financial driver, because more and more hospital environments are driven by finance people and attorneys, unfortunately, rather than doctors, which is how so many medical environments have been started. It is a business, and we should be very clear about that. So cost justification also in a medical environment is definitely important. And so we're always looking for that return on investment. Having covered the negatives, we have to recognize that the technologies are very capable of helping a healthy business environment to become more efficient, to become more cost effective, to get a better return on that investment. And as long as we implement that technology carefully and know what we are doing, and that is why you are here, to learn about how things can be done, should be done, and hopefully that part of the gospel will be spread after this week. And they're definitely enabling technologies, and in fact, when people start looking at this technology, the technology itself, the AIDC technology, becomes a real challenge to current business practices. Okay, here is this existing situation that we want to do better by implementing RFID, let's say. Is that going to work? To what extent are we discovering maybe some flaws in the existing situation, in the existing program or plan that we are running in a business, when we are looking at the different technology? So it is one of the benefits of looking at the technology, see to what extent can we actually improve the fundamentals of this very environment. We have been looking, or the industry has been looking at where is the technology primarily used. And these numbers are not last year's. It's been a little while that they have been around. What is interesting is that shipping and receiving, warehousing, inventory management clearly covers a very large part of the cost justification. We see data quality. Data quality has to do with the fact that if we improve the way how data are entered into our system, we can achieve incredible gains. Rather than writing on a notepad, rather than using a clipboard and pencil, rather than using a keyboard, if we can enter data in a secure and safe manner, then we definitely have an opportunity of improving the quality of the underlying data into our system, which is one of the reasons why people, one of the important reasons why people will start implementing barcoding, RFID, biometrics, and so on and so forth. The visibility again relates very much to inventory management, shipping and receiving, the supply chain. When Procter & Gamble ships a truckload full of Tide to Walmart, they would like to know when that load is, where that load is at basically any point in time, but particularly when it's being delivered to a distribution center or when it's being delivered to a store. Collaboration, production control, reduction of theft and those other elements are important, but these are the big numbers. Here are the big numbers for justifying the implementation of the technology. We sort of came up with this catchphrase that said, "I wish I knew," and that is where hopefully the answers are coming from. Where are you losing money in your processes? Where is it that improvements can be achieved relatively easily? Where can we save that money? And very often the question is, do we really know? Do we know or don't we know where we are inefficient, where we're losing money, where there is space for improvement in our processes? And hopefully the consideration of looking at the technology may help you change some of the fundamentals or improve some of the fundamentals in your organization. Here's an example of Woolworths, one of the retailers in the United Kingdom. They believed they had a significant shrinkage problem, but they were not sure. They were not sure because they just didn't have the data. They didn't know what was going out of the distribution centers. They didn't know what was being received in the retail outlets, and then they didn't know if they were stocked on the floor. What happens to be the case, and many of you may or may not know this, but most of the shrinkage in a retail environment is not set by customers. It is, unfortunately, employees or people that are involved in transportation of the goods between the manufacturer and the retail store in its different phases, where goods are falling off the back of the truck. So it is important that we know where things are, and Woolworths was very much concerned about it. And this is what they implemented. They scanned items into totes, and you can read this. They tracked the goods basically from the distribution centers into the stores. Rather similar applications more recently were by Pfizer. Pfizer happens to be the manufacturer of Viagra, one of the most faked medication in the world. And they started implementing pilot schemes to test whether RFID would help them keeping track of the product actually from the production line all the way to the retail store, to the pharmacy. I don't believe that test has been completed all the way to the end, but I know that they have been very successful in tracking the products from a manufacturing environment, particularly in Puerto Rico, to some of their main distributors like McKesson, and they have had some significant successes there. So then the other question is, and we encounter this, people that are in this business on the selling side, we encounter this very often, and particularly in the environment of my client, Axicon, which is a company involved in barcode verification. We very often get telephone calls from companies saying, I need a barcode verifier to check the quality of what we print or what we receive on the receiving end of the supply chain. And when we have a little discussion with this client, we often discover that it's not their wish to get into verification. It is because their customers insist on the quality of the barcode being high, and therefore the quality of the barcode being verified. And we see this, this is not just in verification, but we see this in many sites in the use of the technology, where they are forced by other players in the supply chain to implement barcoding or RFID. So they'll be forced, or is the reason for implementing it your desire to create a better business environment and to run your business more smoothly? And one is not exclusive of the other. both may apply. But sometimes what we see is that being forced into looking into implementing barcoding and RFID and so on, we may discover internally what the benefits would be. I remember the early days when there was this chicken and egg discussion about why should I put a UPC code on my box of Kellogg's cornflakes? Nobody is scanning. It was really a chicken and egg situation that obviously needed to be broken. That vicious circle needed to be broken, and it was obviously broken because every box of cereal now has a barcode and has had for a very long time. But what some companies were saying, well, first of all, I'm losing real estate on my package because the barcode takes up space that I could use for advertising and marketing purposes, although it's often at the bottom of the box, and therefore, to what extent do you use that space for other purposes? But also, there is cost involved in doing it. You need to get the barcode number, you need to implement it, etc., etc. Very often companies started looking at how can I use this internally rather than being forced by Walmart to do this or by Kroger here in Ohio. What can I derive from it myself internally rather than putting it on because my customer is forcing it? So we have those two driving forces to help us get into the implementation of the technology. Of course, it's all over. There's a lot of scanning going on in the retail environment. We've all seen that. There are a lot of common applications: inventory, work in process, time and attendance recording, shipping and receiving, quality assurance, asset tracking, etc. You will hear a lot about that this week. One of the earliest applications was blood banking through Eric Brodheim's New York Blood Center. The purpose here is basically very clear, and it is what you find in blood banking that you find in so many other applications. What happens once the blood has been taken from your arm and you're the donor? It goes into a bag. The bag, is either processed and platelets are taken out or whatever the processing is. It goes into a freezer. It comes out, or maybe not a freezer, but in a cooling environment. It comes out and is being applied to somebody who needs your blood, or maybe yourself, if you sort of reserved your blood before an operation. There have been significant numbers of mix-ups. Not so much in who was the donor and who is the recipient, but much more in simple things like the blood group. And if you receive blood of the wrong blood group, then of course that can have detrimental effects. So there was there is obviously a matter of health, or the application is driven by health considerations. But let's not forget that when a hospital applies wrong blood to somebody, there's always a lawyer that says, I'm gonna get it. And of course, then it becomes a financial consideration at the same time. But that's a big driver. This was one of the early applications for the use of barcodes, where you keep track of who is the donor, what is the blood group, where is it going, is it being transferred from center to center, all the way up to the moment where the blood is then being given to the recipient who needs the blood. It was a matter of life and death, but there's also very much an economic driver behind it. You'll find many different applications in manufacturing, transportation, distribution, and a number of these applications, and you can read the column here on the left, and the rows at the top, the rows here and the columns at the top, where there's a lot of commonality between applications. If somebody said, well, there's an application for, I think we have a laser here, there's an application for field automation in government then you would say, well, I don't see that. I see field automation in, for example, delivery drivers that bring the fresh bread to the back of the supermarket store. The direct store delivery is a typical example. But think of it in terms of the guy that walks around and collects the money from parking meters. Now that's typically a government application. So that would be field service application where we record the number on that parking meter, and then the guy counts the coins or their weight or whatever they do with them. But it is that kind of an environment where this application is managed. So of course government also has a lot of fleet. Fleet management is something that works really across all the different application environments, manufacturing, transportation, et cetera, healthcare, and sort of other applications. Okay. Keeping track of things is sort of a very common theme in AIDC and AIDC technologies. Keeping track of parts, inventory, items and documents, and people. Keeping track of items and documents, and I don't remember if there's a slide on, yeah. If we think in terms of keeping track of things, can anybody mention a company that would go broke overnight if there wasn't a barcode involved in their package?
UPS.
Sorry?
UPS.
Yeah, UPS, FedEx. We're not advertising for one particular company, but all these guys, the overnight delivery companies, if barcodes were not on the labels on the packages, these guys would go broke overnight. Because if they start manually sorting packages, I mean, that today is an absolute impossible task because of the sheer volume of shipments that are going through their distribution centers. Keeping track of people. If you flew into Athens, Ohio International Airport, and you looked at your boarding pass, there certainly was a barcode, be it a two-dimensional code, which we will discuss later today, or be it a linear code, like the one this is a linear code. Then the purpose of that was keeping track of you. Make sure that after you have checked in, you also board that plane. And by the way, there's also a linear barcode on your baggage tag to make sure that that bag belongs to this passenger and goes on the same flight. Unfortunately, airlines are not always so efficient that they always have your bag on your flight, as we well know, but still barcodes then afterwards allow them to recover the bag. And how often have we seen bags coming in with a rush tag on the conveyor belt and the airline associate scanning that tag on the conveyor belt just to make sure that the system knows that the bag has arrived at this particular location, et cetera, et cetera. And again, barcodes help these airlines on their sortation systems. When you have a transit time of 45 minutes at Atlanta Airport, my personal experience has been that the bag makes it to your next flight because they have very efficient sortation systems that will do this. There is somebody in the audience here who has been involved in this very early application, Dave Allais, when he was at Intermec. One of the early applications, or sort of oddball type of applications, is actually keeping track of bees going in and out of the hive. And if you can imagine the complication of putting a little barcode on the back of bees is sort of a challenge. You can't use an automatic labeler. I mean, it's sort of a very challenging activity. Cockroaches may be less pleasant than bees, but here's a little story about how cockroaches were followed through the United States with the use of barcodes. And there was $1 million. I don't know how long ago this was, but it looks like it was in 2000. And 4 of them were found in Buffalo, but they started in Arizona. So they have very fast legs, I'm sure, because cockroaches don't fly a lot, I don't think. But cockroaches have a tendency of creeping into all kinds of things, including transportation, maybe vehicles and so on and so forth. So they don't necessarily travel by their own, on their own account and their own strengths. More of the odd and fun applications, however, it would probably be difficult to justify this in financial terms. You know, we don't like cockroaches in general, whether they travel or not. And then there are lots of other applications for the technology, and this is a sampling of some 2D codes, and there'll be a lot of talk about 2D codes this week as well. Be it on printed circuit boards, be it on blades of aircraft engines. In Cincinnati, Ohio, we have GE aircraft engines, and every single blade that goes into an engine carries a 2-dimensional barcode. You can imagine that putting a label on a blade is not very efficient, because with the speed that these things rotate and the temperatures involved, that label would disappear very quickly. So they are laser etched or engraved into the blades, and therefore also don't necessarily change the balance of the blade, which is very important. You see here on the right actually a little, 2D code. A little 2D code etched onto the top of a pin. So they can be pretty small, depending on the quality of the engraving technology used. Keeping track of tools. Keeping track of tools, we see this is a regular tool, a pair of pliers. Where keeping track of tools is important in a medical environment, in the operating room, when the number of tools that came into the room is not the same as what is leaving the room, we have to assume that it's either in the pocket of one of the nurses, which is unlikely. More likely would it be that it's been left in your body before they suited up. So, again, keeping track of animals, using RFID, many different applications. One of the early ones was keeping track of racehorses. And there's a very good economic reason for doing that, because racehorses are kind of expensive animals. And they would inject a little glass RFID tag in the neck of the animal. Here you see in such a tag. These are no longer than half an inch or so. And the reason is we can keep track of the animal. There's no swapping or switching of animals during transportation, for example. Another important application is the food tracking activity that is currently going on, where we try to keep track of beef from the farmer all the way to the supermarket shelf, because if something goes wrong with in the food supply chain, then we want to be able to trace it back to the grower. If there's an E. coli problem, or if there is another health risk involved in food, and the food tracing at the moment is a hot topic in the AIDC environment, and it's one of the earlier applications. There have been a lot of cows and pigs that have either a barcode or now also more and more the RFID tag inserted into their bodies or attached to their ears. By the way, as a little anecdote, it turns out that with pigs it's not a good idea to put it in ears, and maybe rather at the tail of the pig, because pigs apparently, and I've been told this is not personal experience, have a habit of nibbling at each other's ears. And so they might, and this is not necessarily an approach, an amorous approach, they just happen to do this, and therefore you might lose tags if we put it in the ears. Here's an interesting application that you may not have thought of. This goes back to the construction boom in Dubai in the Middle East, 2008 this happened to be, where 25% of the world's population of construction cranes was in Dubai. Another quarter was certainly in Shanghai, where all these towers were going up. And the people in the Middle East typically have a habit of not wanting to work very hard, so they import labor. And so they get a lot of workers from countries like Bangladesh, India, Pakistan, countries in that general area, Sri Lanka, and they were being transferred in and out of the construction sites by bus. And so when a bus comes in and you have your time clock to keep track of these people, that was slowing down the whole process of moving these thousands of workers into the construction sites. The solution that was found was to put an RFID tag in their helmets, and so the tag would be on the inside of the helmet, so that when they walked through a gate, they didn't have to do anything. There was an automatic detection of who was coming into the site. Now the assumption is that they used their own helmet and not their friend's helmet. All right. So, but they would walk through a portal like this, and it would be recorded. Actually, a very good application when you think about it. It is very efficient. It's cost efficient. And it's multiple use of the tag because it stays in the helmet at all times. Here we have a chart that shows, it's a typical chart that is used to demonstrate the life cycle of different technologies. And there is sort of a new technology develops, and then you get a lot of hype. And at the peak of the hype, people discover that there is a lot of disappointment. There's a lot of promises that have been made. And then so you get that trough of disillusionment. And then it starts building up, and this becomes now real life. Now this is really where people are seeing and deriving the benefits from the implementation of the technology. And it's a chart that's probably 4 or 5 years old. But it clearly shows you where the different technology, and you could draw a chart like this for each of these dots on the slope, and you can see where each of the technologies would be in their life cycle. For example, if we take 4G, at this point 4G was still very much hype. At this moment, 4G is clearly up here on top of the slope. It is being implemented by all the carriers, and you can follow all of these. By the way, all these charts are going to, or this entire presentation is going to be in your handout, which I understand is no longer a big binder, but a more modern way of doing it. And so, if we look for well, for example, biometrics, which is definitely one of the technologies in automatic identification. At that time, it would be sort of here. Maybe biometrics have known some issues on the disillusionment downslope. And here you see biometric user identification. But it is definitely much more somewhere here in its development. And you know that if you travel internationally, you're coming into the United States, you definitely want to have your biometrics. They take your picture, and that's not just a beauty picture, that is one that goes into a file and can be identified. They take your fingerprints, so you can be identified and found as well. I'm talking about foreigners coming into this country. I'm not talking about US citizens. Because for US citizens, your new passport will have an RFID chip, and that RFID chip will have your biometrics. Because when you applied for your passport, that is what happens. It's not so much your fingerprint, but it is your picture, right? So we go from the technology trigger through the inflated expectations. And for those of us who have been in this industry, we know that there have been phases for different parts of the technology. And basically every single technology has gone through this. There's a lot of hype, they get the disillusionment, until people start recognizing the benefits that can be derived from the technology. And you get that slope of enlightenment. And then it gets into real productivity. And it becomes so ubiquitous that people forget that there has been this whole slope before it. So let us look at good business management. Make good decisions. Good decisions are based on good information. We need good information to be able to make the right decisions. However, we have to be careful that very often we work with historical data. Think of the clipboard. In the days of the clipboard, we were recording events or we were recording transactions on paper. They would then be keyed in, and then at that point it becomes a real historical piece of information that is only has limited value in the complete application. So one of the things that AIDCTI technologies are trying to do is to make the information available, data available right at the beginning or right when they are generated, so that we can work in a much more real-time environment. That is what the technology to a large extent is all about. It's the accuracy, but also the timeliness of the information. And everybody is trying to control something, whether it is cost, whether it is time, schedule, inventory, location, etc. It's all a matter of control. However, what we get out of the information is data, and it is with the data that we will be working, regardless of how the data is getting into the system. It's all bits and bytes, which we can enter by keyboard, but those days are gone. We use AIDC technologies to enter accurate data rather than data entered with human errors through a keyboard. So you get the data capture, we input the data, we process it, and we have an output. It's basically IT environment. And the evolution is that in the 60s we had centralized computing. We remember, or IBM is just 100 years old at the moment. One of the highlights in IBM's development, I think, was the creation, and I certainly remembered it. I once even wrote a program for an IBM 360, at which point my employer decided that maybe I was not very good at writing programs. I was much better at explaining why my program didn't work, so they put me in sales. In the 60s, centralized programming, or centralized computing. Then in the 70s, we got more into branches, distributed computing, followed by personal computing in the 80s. In the 90s, it's all network computing. And as we get closer, because what is happening here? We're going from one big computer to smaller, to smaller, to smaller, where at the moment we can do an incredible amount of stuff on a BlackBerry or on an iPhone. We can do more on an iPhone today than in the 60s we could do on the biggest IBM 360. So there's definitely technology. However, what that also means that as this technology of computing gets closer to the location of the event, the more critical it is that we get accurate data. Because with the speed at which we process data at the moment, it is an incredible fact that as we enter rubbish, it gets processed much more quickly, generating even bigger rubbish. So it is important that the quality of the data is there and that we get to where we are today, which is the mobile workforce. If you're traveling by air, it's probably an environment where you see a lot of people use their iPads. People don't log their large laptops with them anymore. I don't think that it's easy to do a spreadsheet work on an iPhone or on a BlackBerry, but with an iPad, there's no reason why you couldn't, and a lot of people do. It's not just for reading books or sending messages. A lot of computing power available in these devices. So let's go back to data, information, and knowledge. Data is entered, information is created, and what it does is it gives us knowledge. It gives us knowledge about an event, it gives us knowledge about a situation, it gives us knowledge about the whereabouts of a good, and people use these terms interchangeably, but they are not. Data is where we start. We process it into information, and the information gives us knowledge that we can work with. So what is the difference? I did not invent this. This is from Davenport and Prusak. The data are entered, the information is processed, and the knowledge is the result of what it is that we are working with. Data is basically the alphanumeric representation of things, events, part numbers, dates, times, employee numbers, you name it. Parts on a parts list, a date, a person. That is all data. Information is where we put the data in a certain context. For example, Mr. ABC is walking through this door. We either read his badge by barcode or we have an RFID tag, and we now know that Mr. ABC is in this room. That's all we know, but at least we have that connection between the data and the information that's processed, the data, the person and the location, I should say. Those two are now tied together. And so we're talking about transactions. That was a transaction. Who did what to what thing and when? When we think about that question, who did what to what thing and when, we're talking about the who is the employee number, the part number, the quantity and the location is, and maybe time and date for the answer to the when question. This will put it all together. Now we have information. Now we have a piece of information. Knowledge is when we apply that information in the context of some rules so that we can determine, or we will have knowledge of what and how many should we order if we are running out. Okay, so I'm coming to the end. I'm in a supermarket, and I have one of these gadgets where I can scan the tag. I can either scan the product or I can scan the tag on the shelf, because I see that there are only 3 pieces left. That is data which I enter. The information says there's only 3 pieces left. The knowledge now is hey, I better do something about reordering these items because we're going to run out. So we have the decision of how many should we order. That's a human decision, or it is an automated decision that says, when we order the box of Tide, it is also always 5 pallets, for example. But we also have to ask the question, for example, is it time to replace it? Because maybe we say, well, we don't want to carry Tide anymore, which I guess in a supermarket environment would be rather detrimental. So again, we have the data that lead to information and that then results eventually in knowledge. And with the knowledge we can do something. What Mr. Disraeli has been dead for a few years, but this is what he said as a general rule: the most successful man alive is the man who has the best information. And I think that's true. And it doesn't have to be man as a man, it could also be a woman. But the more we know about the situation, the more information we have, the better decisions we can make. So what is the purpose of AIDC? Keep that in mind this week, please. Do me a favor. We put the right information in the right format, in the right hands, at the right time. Okay? Those are the elements that we're trying to put together in the collecting of data and the processing of the data, so that we have confidence in the quality of the data, that we know that the data that are going into any system, be it a tablet that the UPS driver is using to record the fact that he has picked up a package at your office or has delivered a package at your office, that we know that the information is accurate and it's there. That is one of the goals that we try to achieve with AIDC technology. Quality of the data, when we talk about the quality of the data, we have to look at the metrics that we use. And so, is it accurate? Is it timely? And yes, it is timely when we use AIDC technology. It's accuracy. It's fast, reliable. We use fast and reliable computers. We have amazing networks. We have superb software, but we also have to be sure that what goes into that whole IT infrastructure is of the required quality. Historically, we in the industry have been using with this example that 1 in 300 keystrokes on a keyboard is an error. And that all depends, because when I'm typing, it's 1 in 15. And so this varies from person to person. But it is important to keep that in mind. And that is one of the reasons why barcoding and other technologies is so important. We briefly mentioned earlier 7,000 accidental deaths each year through medication errors, which from ordering to transcribing to preparing to administering all have their own percentages, from 39 here in ordering to transcribing to administering and then or preparing and then administering. So those are the two big areas that are error prone. And what we're trying to do is to make sure that the doctor is identified, the nurse is identified, the patient is identified, the medication is identified, the patient's chart is identified. And I've been in a hospital environment, not personally, but visiting somebody, when the nurse came in, rolled in her PC, and was scanning every one of these things. Her own badge, the bed, the patient's wristband, the unit dose of medication, and tying it all together. I have not seen an alarm going off saying this patient needs a sleeping pill rather than an aspirin. But that is the idea behind that application. It's tying it all together and increasing the accuracy of the data. Humans are slow, we know that. The humans are error prone, some more than others. And we find that the probability of making an error is getting pretty significant if a human is involved. And here's one of the problems that I, in the beginning, alluded to in the case of India. People that are hired to enter data are often minimally skilled. This was maybe less the case when we had these rooms, and many of you may not remember this, but these roomfuls of key punches where we were keying data into punch cards. These women, primarily women, were trained to enter accurate data because in those days there was no check on whether that data was actually punched correctly into those cards. That would be discovered much later when the cards were being processed. Today we can identify those errors much more rapidly and more right on the spot. But as we have that distribution of computing power and more people have access to and the responsibility for entering data, it is important that we have a check on that accuracy. And this is where the AIDC technology comes in and helps. And I may be a little bit repetitive, but it is an important factor to keep in mind. Here's an example of writing, and so you can read this, and this is sort of enlarged. Well, what does it say? Does anybody venture a guess what it is supposed to say? Well, let me help you. It could be 1SDG02VC. That's a possibility, in which case it will be a light bulb, let's say. It could also be 15060Z2L, which would be a boat anchor. And there's a little bit of a difference between the two. And so handwriting is fine when you write love letters and all that stuff, but in the data environment, there's no place for it anymore. So yes, do people make errors? What are those errors for part numbers, SKU numbers, inventory quantities? That's the accuracy part. The timely part is that with the use of this technology, we capture the data where the data are most valuable. Over time, the value of the data diminishes. When I'm in a production environment and I'm making widgets, it's important to know how many widgets I make. After 1 week, I'm really not interested anymore. It is today, Monday morning, that I want to know, my boss wants to know how many widgets I've made. After 2 or 3 days, or 1 week, 1 month, all of that is irrelevant, or less important. And because we're working in a real-time environment. Smart business is making good decisions, and for good decisions you need good information. But we also need, so that we have the right knowledge about events, people, occurrences, and so on and so forth. Let's forget the historical data. Let's go to where the data become significant, meaningful, on the spot, where the time between capturing data, processing the information, and creating knowledge is reduced to a few milliseconds rather than a month. Bill Gates, we may have heard of, once said, too many managers seem to take the absence of timely information as a given. And we all know that that's a very true statement, but it doesn't have to be that way. And that's why you're here this week. So what is the point? The point is that we want accurate and timely data for decision making. Because ultimately, why do we do all this stuff? We do it because decisions are being made, either for us or by us. For us, because we may have automated the process in our IT system that says, when the inventory level of widget XYZ gets to this level, we need to reorder. That's an automated process. Or I get the information and the knowledge about an event and a situation, and I can take a human decision to do that. So that ultimately we do this because we want to we want to have the confidence in that what we work with is indeed accurate, timely, etc. What's the smallest, what happens when the smallest piece of data is wrong? Well, we get back to this inverted pyramid. And we have an example here. It's the purpose of decision making. And again, Bill Gates can't keep his mouth shut. Said, know your numbers. You need to gather your business data at every step of the way and in every interaction with your customers and your partners. And that is so wise. Now, he wrote this in 1999. 1999, we were in the middle of implementing barcodes all over the world in all kinds of applications, all kinds of environments. Not necessarily RFID to a large extent, but RFID started developing at this point. In fact, the technology has been around a lot longer. You'll hear that this week. But from an implementation point of view, we were still in its infancy. And so we have supply chains. Here's sort of an overview of how different applications or different technologies may be used at different levels in the supply chain. From the large containers to smaller packages to individual items, we use different technologies. GPS we would use at this level, where we can keep track of containers and so on and so forth. A lot of GPS used in keeping track of trucks. Not so much to keep track of the trucks, but keeping track of what's inside the truck. RFID, obviously, because we need to identify. GPS tells me what my location is. What's inside, we use RFID. Active RFID, because we're working over fairly large distances. In that middle part, which is the container part, you will see all kind of technologies used that will be covered this week. And again, on the item level, there is obviously barcode. Sorry about that. And some historic pictures, actually. And RFID and voice, very much used. The value of visibility, we talked about it. FedEx, DHL, UPS. Capture every interaction, share the information internally, externally. And so the value of visibility, we talked about this with the UPS tag. We can, on the UPS website, follow entirely where a package has been, and where we can expect it to be delivered to us. The value of visibility is very high. The visibility, of course, in the supply chain. Here we have an application by Boeing where they capture data on the quality of some of their parts. They're fed into a central computer system, and that results, or with that data, we have knowledge of schedule interruptions, flight hours, landings, etc., and it ultimately leads to information that goes to the repair facility when a part needs to be repaired and removed and repaired. So let's forget that keyboard. We're not going to do that anymore. We can use the keyboard to write letters and emails and so on and so forth. But for the rest, we are going to use AIDC technologies in their different forms. And rather than losing money, we're going to make money. Data capturing is a process that involves people, materials, methods, machines, measurements, environments. It involves a lot of different things. But it is basically a systematic data capture system by means other than manual notation on the keyboard entry. Barcoding is obviously one of those technologies. Barcode is more than 30 years old. It starts from the early days here to UPC code to further development in the 60s. I don't know why the 60s are not up front, but that's another story. Code 39, etc. Further developments of linear codes. Then we get stacked linear codes, and currently the world is very much driven by different two-dimensional codes, and we'll talk a lot more about that later. How are we doing time-wise? Kevin is not here.
About 45 minutes.
45 minutes for the whole thing?
Yes.
1 and 2?
Yes, both parts.
Okay. So those are the technologies that we are going to cover this week. We'll be talking about barcodes, radio frequency identification. Magnetic stripe is probably going to be covered, voice, smart card biometrics, and OCR. OCR is one of those technologies that is still very much around and nobody talks about, but it is definitely still around. The goal of AIDC is to get accurate and reliable identification of physical objects in real time and in meaningful detail, so that we have meaningful knowledge of events and things. There's obviously an opportunity for errors in many phases, and if you look at the more traditional way of doing things, we observed, we recorded, we reviewed, we did key entry and into a database. Now, in real data capture and real time, we observe, we key enter into a database. However, with data capture in an automatic manner, we go straight into that database from the moment we record a transaction or an event. In fact, the technologies of AIDC are very robust. They've all been tested for a long time, are widely available. In all technology, have a large number of competitors, or I should say a large number of companies that are all competing with each other. And that, as such, assures you of the quality of the products, because if you manufacture rubbish, then people will not buy your goods. It is robust. It's inherently error resistant at character level and word level, and we will talk about that when we talk about barcodes, and we will talk about it when we talk about RFID, for example. And we can also make them error resistant at a message level. We'll cover that later through error correction. Code 39 is one of the older codes. In fact, the inventor of Code 39 is in the room, Dave Allais. Code 39, one of the characteristics of Code 39 is that it is an alphanumeric code. Wait a minute, I think we are. Okay. How do I switch off the screen? How do I switch off the screen?
What do you want to do?
Well, I want to have a quick look at whether I'm still in presentation 1 or 2. Looks like I got into 2.